Hello everyone and welcome to our new section which is called Stack. With this lecture we begin a brand new section in which we will learn everything about stacks. In this section you will get a deep knowledge about stacks, which includes creating stacks based on arrays and linked lists. And we are going to perform operations like creation, pushing, popping on these stacks over here. Now in the first lecture, let's see what is stack. So let's get started. The structure of stack can be imagined as a pile of objects stacked vertically. When extracting these objects, the last added to the stack is the first one removed. The real examples of stacks can be pile of dinner plates, pile of books, or bangles in hand. So for the explanation, let's look at pile of dinners over here. So if you observe the properties of this pile of dinners over here, we can easily see that we have LIFO method over here, which stands for last in and first out. Now what do we mean by that? So let's see. So we can clearly see that these plates over here would have been placed first, then we place this place, then we place this place, then and it continues until we reach the last plate over here. Finally, this plate is the last one which is inserted in the head of this stack over here. Now if we want to take one plate from this pile of plates over here, we have to take the last plate from here. If we want to take the first plate, we have to take all plates, then we come to the first plate. Otherwise, if we take the first plate, all other plates over here might be broken. That's why it's very advisable to take the last plate, then the second last, and it continues like this until we reach to the plate which is placed first. So here you can easily see that to take the first plate, we have to take all plates that are located on it, and only then the first plate can be taken. So here you can see that whichever place comes last, it has to be taken first. So we have placed this plate over here last, and we have to take it first over here. So this property is called LIFO property, that is last in, first out. Similarly, the stack data structure follows the same property, that is whichever elements come last, it has to be taken out first. So let's quickly see example of stack data structure in computer science world. So here we have a stack which follows LIFO method. So first we are inserting 10 over here, then we are inserting 20, then we are inserting 30, then we are inserting 40 over here. Now if we want to remove the 30 from this stack over here, first we have to remove 40. So the order of removal will be like this. 40 will come out, which was the last element that we have inserted to our stack. So it was the first element that comes out, then the 30 comes out after the 40. And it continues like this until all elements removed from the stack over here. So now hopefully you have understood what exactly stack data structure. Now you might be interested why we need a stack data structure. We need a stack data structure whenever we need a functionality in our application that utilize the last coming data first. So the classical example for stack data structure is back button in our browser. So here we have a browser, so there's a back button over here. So the functionality of back button works exactly same as stack. So it follows the principles of stack over here. So let's say today when I open my computer over here, first I browsed Udemy, then I checked my email using Gmail, then I see that there's a notification from LinkedIn, so I clicked on this notification and I visited LinkedIn. Then at the end, I have visited my own website, which is appmillers.com. So currently we are at appmillers.com. So what will happen if I click back button over here? So it's clearly that it's going to go back to linkedin.com. Then if I click back button one more time, it's going to go back Gmail, because before LinkedIn I have visited Gmail. Then if I click back button one more time, it's going to go to the udemy.com, because before gmail.com I have visited udemy.com. So the way that back button works, it follows the principles of stack. So you can see that the website came last, it has been utilized first. So the website that we have visited last was appmillers.com, so it has been utilized first. So if I put this functionality in the form of stack, the first website that we have visited was Udemy, so Udemy is inserted over here, then Gmail, then LinkedIn, then appmillers. So if I click the back button, first appmillers will come out, then if I click one more time, linkedin.com will come out, then gmail.com will come out, and then udemy.com will come out. So when extracting data from the stack, the last one, which was AppMiller in our case, came out first, then it continues like this. So as you can see, it works the way that back button works in the browser over here. So back button can be a real life example for stack data structure over here. So with this, we have come to the end of this lecture. So hopefully everything is clear about the concept of stack data structure. Now in the next lecture, let's start learning operations that we can perform on stack data structure and how can we implement them. So see you in the next lecture.